Topic 1, Day 4, Geometric Sequences and Series. So we know that sequences are geometric when we multiply them by a constant value in order to get to the next term. That constant value is called the common ratio, and we use a variable r to denote the common ratio. For example, if we have a sequence 5, 10, 20, 40, it has a common ratio of 2 because we're multiplying by 2 in order to get to the next term. So our notation here, if we're going 5, 10, 20, 40, where 5 is our first term, we denote that n is 1 because n is the first term. The value of the first term, a of 1, is 5. Similarly, for our second term, n is 2. The value of our second term, a sub 2, is 10, so on and so forth. And then again, we know that our ratio is 2 because we're multiplying by 2 in order to get to the next term. In order to calculate our common ratio, we can divide a term from its previous term, right? So similarly, if we're looking at our original sequence here, we can take the second term and divide it by the first term. So we're doing 10 divided by 5, which gives us 2. But similarly, we could do a sub 4 divided by a sub 3, and we get 40 over 20, which would also give us our common ratio of 2. In order to find the nth term of a geometric sequence, we can use this equation. A sub n equals a sub 1 times r to the n minus 1 power. Okay? And if we're trying to find the sum of n terms, we can use this sum equation. All right, they're the same. There's not really a blatant preference or like an advantage for using one or the other, so you do you. So in our first teacher example, we're given the geometric sequence 75, 375, 1875, and we're trying to find the 7th term. All right, so by looking at it, I already know my first term is 75. I know that I can calculate our common ratio, and I know that my n value is 7 because we're looking for the 7th term, and we're searching for a sub 7, right? To find our common ratio, we can take the second term divided by our first term. So if we're doing 375 divided by 75, we get 5. Now, since this is a geometric sequence, we're going to use our equation. A sub, in this case, 7, will equal our first term multiplied by the common ratio taken to the n minus 1 power. So a sub 7 is going to equal 75 times 5 to the 7 minus 1 power. And that gives us the value of 1171875. And at first, you might be like, oh my gosh, that's such a big number. How do we know it's right? But if you look, we're multiplying each number times 5, right? So the numbers are going to get drastically big pretty quickly. And 7 is a pretty easy number of terms to check. So if you want to use your calculator, double check, you can see that that is our 7th term. Go ahead and try student example number 1 on your own. Now, teacher example number 2 says that given the geometric sequence, -4, 12, -36, 108, determine the sum of the first 20 terms. Okay, so again, we know that our first term here is -4. We know how to find the ratio. We'll do that in a second. We know that our n value is 20, and we're looking for the sum. So we're looking for the sum of the first 20 terms. In order to find our common ratio, we're going to take a sub 2 divided by a sub 1, which gives us 12 divided by -4, which is -3. When our common ratio is negative, you'll see that our first to second term goes from negative to positive, and then it'll alternate, right? Because when you multiply by a negative, negative times a negative is a positive, positive times a negative is a negative, so it'll keep going back and forth. In order to find the sum of our 20th term, I'm just going to use the first equation. S sub 20 equals a sub 1 times r to the n power minus 1 over r minus 1. Okay, just be careful when you're plugging in all of these numbers. -4 times, and then we're going to take r, -3 to the 20th power minus 1 all over -3 minus 1. Okay, put that through the calculator and you're going to get a really, really big number. Again, we're multiplying by -3 20 times. The numbers are going to get big. So S of 20 equals 3, 4, 8, 6, 7, 8, 4, 4, 0, 0. Okay. Try student example number 2.